All right, so let's first define our two interfaces. So notice that now in this case, I can define an interface through here. If I can't, if for some reason it doesn't show up, because if you haven't used it before, it doesn't list there, I can go to Other, and under Java, I find there should be a Java interface. There it is. Okay, and once I do it once, it'll put it on that pop-up for me. All right, so okay, so here's the dessert topping. All right, so let's say eat will be my one method it implements. And let's do another one called floor wax. And it has, well, let's call it wax, okay? Okay, so here, so I'm defining an abstract method here. Again, I define an abstract method by the name. In this case, because it's an interface, it has to be public, can't be anything else. Name, return type, in this case there's no return type. Name, argument list, here no arguments. But as we saw, the action listener interface specified an action performed with this particular signature. So I can have an action performed that has a different signature. There's no law against that, but it will not respond to the callbacks. Okay, so we have our dessert topping interface, our floor wax interface, and now let's define our class. And here's how I say implements dessert topping and comma floor wax. So you say implements, and that comes after extend. So if I extend, so let me be explicit. By the way, this, if I don't extend something else, I can always extend objects. So this is, I always you put extends first, and then implements, and then one or more separated by commas in terms of the interfaces. And so now, okay, so implement all abstract methods, and now it implements both of the methods, because I've implemented, you know, whatever interfaces I've implemented, it will, you know, implement abstract methods will implement all the abstract methods that I'm supposed to. And if I wanted to make this abstract, I could delete or comment out some of these, but then I would have to make it abstract. Let me show you how that could be done. So let's comment out this, and now it's complaining. And then if I just say public abstract class, then it implements one, but not all of the interfaces. So to make this concrete, I would have to subclass this and then implement all of the all the other interfaces. So, but I don't want to do that. And let's all right. Again, we're not, this is not a terribly again, this is it just illustrate the simplest way to illustrate implementing multiple interfaces. Okay, so I have something which is both of these. I can put it into that context, and so let's see how that plays out. Now I have choices. First of all, well, the most straightforward is to define define a variable of that type. Or okay, now what I've done here is I've defined a variable of one of the interfaces, but I have to instantiate it with a concrete class. I can't instantiate an interface. Okay, and this one I've instantiated with the other interface. Okay, so they're all consistent. So I can give my variable any one of the types of its class, of any of its superclasses, or any of the interfaces that it implements. Now, the difference is that with the first one, because I've defined it to be a new shimmer class, I can implement all of it, I can invoke any of its methods. So I can both eat and wax. Okay? And in fact, tell you what, let me, just to be clear, I want to just distinguish the various ones from each other. And notice that the interface, I can actually refer to this, and it's not complaining. So even though I'm actually in a concrete class, so there's no reason for it to complain. All right, so now this is just going to identify who's doing what. So tell you what, instead of all that, let's do just the hash code, because that. Instead of all the, okay, so, all right, so there's my hash code. Now, object 2, even though it's a new shimmer, I can only invoke the eat method. If I try to wax, notice that I can't. Even though, again, this is important to understand. Even though this object has the wax method in it, but I cannot invoke it here because I've only declared it to be one of these guys, a dessert topping, and dessert topping can't wax. Right, so I can't do this. And similarly, the third one, I can wax, but I can't eat. Even though, again, and the reason I keep sort of emphasizing this is because it's not that that method isn't there, it's that the compiler can't guarantee that when the time comes to actually invoke this, that it will be there. In other words, because object 3 has only been defined to be a floor wax, I happen to have put in an object that implements both of these interfaces, but there's nothing that requires that. At some point in the program, and the virtual machine isn't smart enough to kind of parse my code and figure that out, at some point I could put in an object that only implements the floor wax interface, but not the other one, and that's going to fail. So the virtual machine, the compiler, will only allow things that the virtual machine can be guaranteed to invoke, and what that means is that the only errors you're going to get are runtime errors, and that the program won't even run until you clean up all the compile errors. In other words, get rid of all the red squigglies. So now, okay, so here's the both one eating and waxing, and then here's this one eating, and then this one waxing. But then you say, well, I am absolutely 100% sure that even though I've defined this to be a floor wax, I really want it to also be a dessert topping. And so I'm 100% sure that I'm going to be able to treat it like a dessert topping. So what can I do? Do you remember? Cast it, exactly. In other words, I can cast an object to anything which is compatible, anything which stands a fighting chance. And actually, one of the nice things about interfaces is that the virtual machine kind of gives up. If I cast it to an interface, the virtual machine say, okay, you're the boss. Right, so what I can do is I've defined this to be a floor wax, but I also want it to be a dessert topping temporarily. And now it's gonna let me eat it. However, this is somewhat dangerous because this cast could fail. Okay, let me show you what would happen if that failed. So let's do something that is okay, so here I'm just going to implement one interface. And, oops, no, yeah. Okay, so all fine and good. See now, object 3, because I've defined it to be of type floor wax, and now old shimmer is in fact a floor wax. This is absolutely legitimate. You know, this will always work. But now, okay, so the compiler says, says, you're the boss. All right, now what's going to happen here? I'm going to now try to I'm going to try to cast this object to an interface that it does not implement. So if you're the virtual machine, what would you do? Well, let's see. Okay, we have a class cast exception. And in fact, one of the nice things about all this is they have little links. So if I click on where the error was, it takes me right here. And the exception, some of the exceptions are nicely, have a good message, others do not. Let's see it. This is about as good as it gets. It says, this class cannot be cast to a dessert topping. Let's see, did I misspell interphrases? Okay, so if you misspell something, here's where this little refactor thing comes in very handy. Interfaces. All right, let's interfaces. Unnamed module of loader app. Yeah, so basically, I mean, the main message is it cannot be cast to one of these things, and that's about as good an error message as you're going to get. It's very clear. It says I can't cast it. Why can't I cast it? Well, because here's the class I'm trying to cast, and here's the interface. And so what I can do is I can say, well, what happened? Well, I only implemented this. I didn't implement the other one. So casts can be useful if you're absolutely sure that it's going to work. And if you're not, then don't do that. Okay.